Here in the U.S. And keep an eye out tonight and right into the weekend. Millions of Americans could actually see the northern lights as far south as Alabama because of this very rare solar storm. But could this geomagnetic storm also bring possible cell phone, GPS, and internet disruptions?
Any day now, all our technology could stop working because of a massive solar storm. This devastating idea is closer to reality than we think.
Well, we might think of the sun as a solid object or a disk, but it's spinning. About every month, the north and southern parts of the sun, what humans call the north and south parts of the sun, spin a little faster than the middle.
Earth is about to face an extremely strong solar storm, and our modern world is shockingly fragile against changes on the sun's surface. We depend heavily on electricity, communication systems, and navigation tools, all of which could be knocked out by this storm. What will happen if everything goes dark? Let us reveal Bill Nye's final warning about the imminent G5 solar storm that will collapse our planet. The hidden dangers of solar flares. Are we truly safe? We got a glimpse of what the sun can do back on September 2nd, 1859. On that day, ship compasses stopped working properly, leading to the loss of some ships. Telegraph lines even caught fire, messing up communication networks. People as far south as Mexico and the Caribbean got to see auroras, which must have been a strange sight amidst the technological chaos. That event from over 160 years ago reminds us, and maybe warns us a bit too, have we gotten too comfortable? Are our safety measures and backups good enough to protect us from these kinds of solar outbursts? Or are we just fooling ourselves into thinking we're safe? As we look into Bill Nye's warnings and what scientists say about them, it's important to really think about how ready we are for whatever the sun throws at us. The solar storm of 1859, famously known as the Carrington event, was named after the British astronomer Richard Carrington, who first noticed the solar flare that triggered this massive storm. Carrington was a prominent figure in astronomy during the 19th century, particularly known for his studies on the sun. He discovered that the sun doesn't rotate uniformly. Its material moves faster at the equator than at the poles. He also identified the sun's north and south poles and noticed that the dark spots on the sun, called sunspots, change positions over a cycle that lasts about 11 years. On September 1st, 1859, while Carrington was observing these sunspots, he and another astronomer named Richard Hodgson observed a sudden, intense burst of light on the sun's surface. This was the first sighting of what we now understand as a solar flare. Current scientific understanding tells us that this flare was the sign of a coronal mass ejection, CME, a powerful release of solar energy and magnetic fields from the sun's surface. The effects of this solar eruption were felt on Earth the next day. A powerful geomagnetic storm hit our planet's magnetic field. These storms are more common when the sun is at the peak of its 11-year cycle, which includes frequent coronal mass ejections. These are now regularly recorded by our spacecraft. Though people in the 19th century suspected these solar outbursts existed, it wasn't until 1971 that coronal mass ejections were officially detected, thanks to studies using ultraviolet imaging by the Helios satellite. The Royal Astronomical Society was quickly informed about Carrington's observations. This event underscores both the power of individual observation in science and the collective hesitance to embrace new theories. Carrington's work, pivotal as it was, also sheds light on the nature of scientific progress, which can be marked by both brilliant discoveries and considerable delays in their recognition and understanding. His experience raises questions about how we credit discoveries and the importance of both recognizing and verifying scientific phenomena in a timely manner. While Carrington's name remains associated with this significant solar event, reflecting on this historical moment invites us to consider how the drama of the event may have amplified his scientific reputation. It also highlights the gradual nature of scientific progress, often punctuated by moments of sudden insight followed by slow periods of verification and acceptance. This story is a classic example of how science, despite its leaps of discovery, often advances in a hesitant shuffle, taking its time to fully embrace and understand new concepts. An event later called the Carrington event mostly went unnoticed until the next day when Earth's magnetic fields really started to react. This was due to fast-moving solar particles that raced towards Earth. These particles had about 10 circumflex 35 electron volts of energy, severely shaking, compressing, and twisting Earth's magnetic shield. This energy amount can be compared to what a 10 megaton nuclear bomb would release, or what the sun emits in just about 10 seconds. It was, by many accounts, the most intense solar storm recorded. There's a somewhat popular story that tells of a telegraph operator who lost feeling in one arm after being knocked out by a shock. While there's no concrete proof of this incident, the possibility hasn't been completely dismissed either. After the wild magnetic storm calmed down, things on Earth returned to normal. Repairs were made to the telegraph systems, which were the main communication networks of that time, and the brilliant light displays in the sky, known as auroras, vanished. Now let's see how one man's discovery changed our view of the sun. When our star's activity peaks. To really get what happened in 1859, it's important to understand solar cycles, which were discovered by Samuel Heinrich Schwabe, a German amateur astronomer. In 1843, after observing the sun for 17 years, Schwabe noticed that the number of dark spots on the sun changed over time and followed a pattern roughly every 11 years. This was a groundbreaking discovery because it showed that the sun, which many thought was unchanging, actually had its own patterns of activity. Schwabe's work showed that our sun isn't just a constant source of light and heat. It's active and changes over time, which can affect Earth in significant ways. This insight has made us realize that the sun has a lot more influence on our planet than just providing light. It sends out flares and particles that can disrupt our communications and power systems. Understanding the sun's behavior is crucial because it helps us prepare for potential disruptions caused by its activity. Learning about Schwabe's findings in the Carrington event has been essential for scientists and helps the general public understand how vulnerable our modern technology can be to the sun's whims. This event serves as a reminder that our sun, while it might seem steady and reliable from afar, is a powerhouse with the ability to unleash incredible energy that reaches far across the solar system, impacting Earth in profound ways. The sun's behavior is more like a drama in the sky, with each act playing out over about 11 years. Samuel Heinrich Schwabe, who first tracked these solar cycles, might have seen them as a routine series of events, but their impact is far from mundane. The peak of solar cycle 10 in February 1860 and the famous Carrington event just a few months before, in September 1859, remind us that the sun's performances can have serious effects on Earth. During each solar cycle, the sun reaches a point where its magnetic poles swap places. This isn't just a cool space fact. It's a period when the sun throws out massive bursts of energy and particles into space, which can head straight for Earth. This includes coronal mass ejections, which are huge bubbles of gas and magnetic fields ejected from the sun, carrying about 1 billion tons of solar material into space. Sometimes these solar outbursts are aimed directly at us. When this solar material hits Earth's magnetic field, it can create what's known as a geomagnetic storm. These storms can be beautiful, causing bright northern lights, but they can also wreak havoc on our technology. For example, in March 1989, a powerful solar storm caused a massive blackout in Quebec, Canada. The local power grid couldn't handle the electric currents generated by the storm, leaving millions without electricity and causing economic losses in the hundreds of millions of dollars. This event was a harsh reminder of how dependent modern life is on stable technology and how vulnerable that technology is to the whims of solar activity. The 2003 Halloween storms offer another example of solar disruptions. Starting on October 19th and peaking right before Halloween, these storms impacted satellite communications, GPS systems, and power supplies. They were so strong that even auroras, which are usually seen only near the poles, were visible as far south as Florida and Texas. The radiation levels during these storms were so high that airlines had to reroute flights to safer paths, and astronauts on the International Space Station had to take cover. These incidents show us that despite our technological advancements, we are still at the mercy of our sun. Each solar cycle brings with it the risk of disruptive solar events. We often think of the sun as the giver of life, warming our planet and providing the energy that fuels our ecosystems. Yet it also has the power to disrupt our lives without warning. As we continue to rely more on technology, the impact of solar activity becomes more significant. We are continually reminded that our high-tech world is just one major solar event away from potential chaos. This relationship with our sun, dictated by its cycles of magnetic flips and peaks, serves as a constant reminder of our place in the cosmos, capable and advanced, yet perpetually vulnerable to the forces of our own star. In July 2000, a significant solar event coinciding with Bastille Day unleashed a powerful coronal mass ejection that struck Earth, causing more than just a light show. This event, following a large solar flare, draped the skies of North America and Europe in bright, colorful auroras. While these lights dazzled many, they also brought a slew of technological disruptions. Several satellites were temporarily disabled, and critical systems that aid in flight and sea navigation suffered due to jammed radio communications and unreliable GPS signals. This was not an isolated incident of solar disruptions impacting Earth. Back in May 1921, another significant solar storm targeted the northeastern United States and some parts of Europe. This older storm mirrored the chaos of 2000, but had its unique twist. It severely interfered with the telegraph and telephone services, leading to fires in various stations because of the electric currents that flowed waywardly due to the storm. It didn't stop there. Railway signaling was thrown into disarray, causing widespread disruption in train services. These events underscore a rather uncomfortable reality. Our advanced technological environment is incredibly sensitive to the whims of solar weather. The National Oceanic and Atmospheric Administration has a system to classify these geomagnetic storms on a scale from 1 to 5, where G1 is a minor storm and G5 is severe. These ratings reflect the potential havoc these storms can wreak, from minor annoyances to significant damage like widespread power outages and infrastructure failures. Next, we'll learn how past solar storms have shown our tech's weaknesses. Understanding solar threats. When these storms rage, satellites, our eyes and ears in space, find themselves at a loss. They struggle with basic functions like orientation or sending and receiving crucial data. This vulnerability highlights a stark contrast between our technological advances and our actual preparedness for solar disturbances. The reliance on technology becomes almost ironic when the same tools designed to advance our capabilities are knocked offline by natural solar processes. It seems a bit ironic that we find ourselves at the mercy of the sun's moods in our pursuit of technological advancement. While we celebrate our achievements and the conveniences they bring, events like these serve as humbling reminders of our limitations. We are still at the beginning stages of understanding and protecting our technology from the vast, unpredictable forces of space. At 9:49 a.m., it was reported that a major solar storm, classified as G5 or extreme, is taking place. This storm originates from a group of sunspots, which are darker and cooler areas on the sun. These sunspots are huge, about 16 times bigger than Earth. They have been quite active, erupting and releasing solar material every 6 to 12 hours. The scientific community is now preparing for the impacts of these disturbances. Why is this happening now? Well, the sun has a cycle of increasing and decreasing activity that lasts about 11 years, and currently we are experiencing one of these active peaks. Since this cycle began in December 2019, we've witnessed several significant geomagnetic storms, but this is the first one that seems to be a cause for concern, mainly because of the unusually large cluster of sunspots involved. Experts like Bill Nye and other authorities have noted that the activity of this cluster has exceeded what was initially expected. Although the sun will continue rotating, which might lessen the impact on Earth, more flares and material ejections are anticipated. It's uncertain whether these sunspots will reappear on the sun's left side in the coming weeks. And if they do, they could cause more intense solar activity. Should we be worried? Generally, the answer is no. These solar storms have been a natural part of the sun's behavior for billions of years, likely influencing the development of life on Earth. Even though these storms can seem intimidating, they pose no direct danger to people as long as we remain on the ground protected by Earth's atmosphere. However, the situation changes when considering space travel. Solar storms emit extremely high-energy particles that could be harmful to astronauts traveling beyond Earth's protective atmosphere, such as to the Moon or Mars. These particles could be deadly if they received a large enough dose. On Earth, our technology is also at risk. The energetic particles from a solar storm could damage satellites in orbit, which could affect planes flying in the sky by exposing them to increased radiation. They can also disrupt communication and navigation systems. Large-scale power outages can occur if these particles interfere with power grids. The power failure on March 13, 1989, serves as a reminder of the potential chaos caused by solar storms. Even though experts reassure us that there is no need for panic, the threat to our infrastructure and space activities remains significant. As we continue to observe these solar phenomena, it's important to stay prepared and ensure that our systems are robust enough to handle whatever the sun throws our way. These events remind us of the delicate balance between Earth and its place in the cosmos, highlighting the need for ongoing vigilance and readiness in the face of solar activities. 35 years ago, a power outage affected over 6 million people in Quebec and parts of the northeastern U.S. for 9 hours. This event was caused by a solar storm, a kind of space weather that can have even more intense effects. For example, back in 1859, there was a massive solar storm called the Carrington event, which was much stronger than the one in 1989. If a similar event happened today, it could disrupt our lives significantly. Now our world is full of advanced technology, from the internet that replaced the telegraph to digital data streaming through cables across oceans. Our global communication relies heavily on these technologies. In 1858, just before the Carrington event, the first cable was laid under the Atlantic Ocean, connecting North America and Europe. This cable allowed news and information to travel much faster between continents. Today, if another solar storm like the Carrington event happened, the effects could be disastrous. Our world is interconnected in ways it never was before. Almost everything in our daily lives, from healthcare and banking to household appliances and cars, depends on electronic circuits and power. Without electricity, people wouldn't be able to charge their phones. Hospitals would struggle to operate without their equipment, and the internet might go down. This kind of storm could damage every part of modern infrastructure that relies on electricity and digital communication. Consider the broader implications of such disruptions. Stock markets could crash, leading to economic turmoil. Essential services like healthcare and transportation could be severely affected, causing widespread problems, not just inconvenient, but life-threatening. As we think about these potential disasters, it's clear that our technological advancements, while impressive, also make us vulnerable. The integrated circuit, a key component of modern electronics, has ushered in an era of technological reliance. But this reliance comes at a risk, especially from solar storms, which could induce electrical currents strong enough to fry circuits and shut down power networks. Let's explore how our tech reliance might lead to big problems with the sun's activity, the looming threat to our technological world. So while we pride ourselves on our technological capabilities, we must also prepare for the possibility of solar storms disrupting these systems. We need to strengthen our infrastructure and develop contingency plans to handle such crises. Ignoring these risks could lead to chaos, much like what was narrowly avoided in 1989, but potentially on a much larger scale. As much as technology has propelled us forward, it has also tied us to a ticking time bomb of solar activity. Preparing for another significant solar storm is not just prudent, it's essential for safeguarding the societal and technological strides we've made. Picture a world where our dependence on technology suddenly turns against us. A massive solar storm hits, and we're not just dealing with minor annoyances like flickering lights or slow internet. This is a serious crisis where the main supports of modern life, electricity, water, food, safety, and communication, are deeply affected. In this less-than-ideal scenario, our system's interconnections don't show how advanced we are. Instead, they reveal our vulnerabilities, setting off a domino effect of failures. Electric grids might struggle under the storm's impact, especially during a harsh winter, turning a normal inconvenience into a life-threatening situation. Think about the frightening possibility of heating systems failing as the cold intensifies. At the same time, the internet, which many view as crucial as electricity, would face significant challenges. Those strong underwater cables that carry our data across oceans aren't as tough as we think. A powerful storm could severely damage these vital data pathways, turning vast networks into mere pockets of limited communication. Consider further the secondary effects on urban settings where water supply depends on electric pumps. Suddenly, water, a basic need, becomes hard to get, making the crisis worse. In cities like Washington, D.C. and New York, already noted for their vulnerable infrastructure, the problems could go from bad to disastrous in just a few hours. Globally, the impact would vary greatly. Places like China, the United States, and Australia, with their extensive and complex power networks, might face tougher challenges due to a mix of geographical and infrastructure issues. Isn't it ironic? The very countries that lead in technology might also be the most at risk of its failure. And don't forget about satellites, our tools for watching over Earth and outer space. These high-tech guardians aren't safe either. While they handle only a small portion of our data, they are vital for things like global finance. A strong geomagnetic storm could turn them into costly space junk, sending them crashing back to Earth, as happened with the SpaceX Starlink satellites in March 2022. So what does all this mean? Are we setting ourselves up for a big fall by building a fragile system based on our tech dependence? As we protect our systems from known dangers, we seem overly confident, or perhaps foolishly hopeful, about our ability to handle or lessen nature's forces. This situation is a clear warning of our limits and the urgent need to build tougher, more dependable systems. In the end, nature still has the upper hand, and we're just trying to keep up, hoping to predict its next move. This reliance on technology could easily backfire in other everyday scenarios too. Traffic systems, hospital equipment, and even basic communication tools could all fail simultaneously, leading to chaos. Emergency services would be stretched thin, and without proper communication, coordinating rescue efforts or providing public updates would be nearly impossible. The economic impact would be severe as well, with businesses unable to function normally, leading to financial losses and possibly a broader economic downturn. Community resilience becomes key. Neighborhoods and local communities might need to band together to provide basic services and support each other. Local resources, such as community centers and schools, would play critical roles in sheltering and feeding people. This kind of grassroots resilience shows the power of human connection and adaptability in the face of tech failures. Educating the public about these risks and how to prepare for them could also mitigate some of the worst effects. Simple preparedness steps, like maintaining emergency supply kits and having contingency plans, could make a big difference in how communities survive and recover from such disruptive events. Thus, while we continue to enjoy the benefits of advanced technology, we must also keep in mind the potential risks and stay prepared for scenarios where our technological supports might crumble. Everyday activities like withdrawing cash from ATMs or using credit cards could suddenly stop working because of solar storms, those massive bursts of energy from the sun that mess with Earth's magnetic field. This isn't just a minor inconvenience. It's a huge problem that would lead to a complete breakdown in communications. Recovering from such a mess could take years. Experts have tried to understand and explain the impact of these solar storms. They say these storms can create huge electric currents that are strong enough to damage our power system severely. Imagine our electricity grids getting knocked out, and transformers, those crucial parts of our electrical system, getting wrecked. Some studies from the US have warned that many people could be left without electricity for a long time, weeks, months, or even years. And the cost of fixing all this damage? It could be in the trillions of dollars. Bill Nye, the well-known science guy, thinks these estimates might even be too low. He believes the actual damage could be so big that it's hard for us to fully understand. Finally, we'll look at how we're preparing for future solar storms, the quest for solar defense. Now let's think about how often these huge solar storms happen. It's been over 160 years since the last big one, known as the Carrington event. So do these big storms happen often? Or was that one just a rare occurrence? Are these things something we can predict, or are they just random? And if another big one were to hit, how much time would we have to get ready? Understanding what causes these storms is key. They start with something called coronal mass ejections, giant clouds of solar material that the sun throws out into space. We've learned a lot about them since they were first discovered in 1971. But knowing about them and being ready for what they can do are two different things. As we think about the risk from the sun, it's crucial to ask how strong our technology really is. Are our systems built tough enough to stand up to these solar challenges? Or are they too fragile? This isn't just about dealing with a disaster, it's about realizing how small and exposed we are in the vastness of space. Thinking about these solar storms makes us reconsider how much we rely on technology. What happens when the systems we trust fail us? How prepared are we really for a sudden solar-induced shutdown of our modern conveniences? These aren't just theoretical questions. They're practical ones that affect everything from our daily routines to our global economy. And as we look up at the sky, perhaps we should also think about how we can be better prepared for the day when the sun throws its next curveball our way. Coronal mass ejections are bursts of energy and particles that the sun sends out, and they happen more often when the sun's magnetic field changes, which is during the solar maximum. Before the era of electric power, these solar events would have been nothing more than a spectacular light show in the sky, known as auroras. Nowadays, however, our reliance on technology makes us much more vulnerable to their effects. Scientists are using artificial intelligence in an effort to better predict these solar storms. The tools they've developed can provide us with a warning, but only about 30 minutes before the storm hits, which isn't a lot of time. We keep an eye on the sun with both ground-based observatories and satellites. Still, it's tough to say exactly how much plasma will hit Earth during one of these solar outbursts. Even with global monitoring, including the work done by the Space Weather Prediction Center, the specifics remain elusive. When we do detect a coronal mass ejection heading our way, there are some precautionary steps we can take, such as adjusting satellite operations and enhancing power systems on Earth to reduce damage. But these are temporary fixes, and they show just how unprepared we actually are. The effort to protect ourselves from these solar events has been growing slowly. Governments and scientists recognize the potential for a solar storm to seriously disrupt modern civilization. Yet the funding to develop adequate defenses against such a powerful solar event is still lacking, much like funding for other significant threats like asteroids or climate change. We seem always to be a step behind, doing too little too late. The Parker Solar Probe is crucial in our quest to understand the sun better. Launched in 2018, this spacecraft has come closer to the sun than any before, gathering valuable data that helps improve our predictions of solar activity. Yet, as Bill Nye pointed out, this is not enough. The probe only observes the sun from one direction, and to have a comprehensive system, we would need many satellites around the sun, much like the Starlink satellites orbit Earth. It's ironic that the solar activity that might pose a threat to us could also be the reason life on Earth began. The sun, in its flares and storms, could be shielding us from more dangerous types of radiation from outer space. So understanding when the sun is most and least active is crucial, especially for space missions that go beyond Earth's magnetic field. Looking forward, we have started to take steps to protect our technology from these solar incidents. Following a massive power outage, Quebec invested heavily in strengthening its electrical grid. In the U.S., similar steps are being taken, though they appear more geared towards less severe storms, not the massive ones like the Carrington event. More investment in solar research could help, as upcoming missions like the Space Weather Follow-on Lagrange 1 and NASA's Interstellar Mapping and Acceleration Probe are set to launch in 2025 to further our understanding and prediction capabilities. This endeavor to safeguard against space weather is like trying to prepare for a major storm with only a basic umbrella. The Parker Solar Probe is setting speed records as it gathers more data, a testament to our urgent race to understand the sun better. We need to ask ourselves if our dependency on technology is a vulnerability that needs addressing, especially if a severe solar storm could force us to rethink our entire technological reliance. In the face of potential solar disruptions, perhaps it's time we reconsider how prepared we really are and whether our current measures will hold up against the next significant solar event. Make an outro of 30 words, asking a controversial final question, and ask for leave comments and subscribe about this text.